On question 16, the main thing that I wanted us to see on 16 was the lovely top of this guy. Is that in a format that any of us recognize?
Factoring, right?
That's a factoring, yeah. If you just kind of pulled out the signs and rewrote it using like the letter Y in place of sign, it would look like that. And that's something that you can factor pretty easily using your regular trinomial factoring. So just using that on trig is very similar. You would say sine squared is made up of sine times sine. And factors of 3 that add up to 4 are 1 and 3. From there, I would probably look at the answer and say if my answer is all in terms of sines, I probably would like to remove that cosine squared. So what could we put in place of cosine squared? Anyone? 1 minus?
Oh, 1 minus sine squared.
1 minus sine squared, which also factors as a difference of squares. So that means that the top has turned into sine x plus 1, sine x plus 3, all over 1 minus sine x, 1 plus sine x, because that factors as a difference of squares, and then what's going to cancel for us? Sine plus 1 is the same as 1 plus sine, which is essentially our answer there. Okay. Other ones we'd like to go over?
Miss Leininger, I just had a question.
Yeah.
I haven't really used the double angle identities for anything, and I was just making sure I wasn't like forgetting to do things.
Yeah, you're not forgetting. Those come up kind of rarely.
Okay.
They do show up in some, like, to be honest, like if you go through, well, okay. So it's hard to find proofs with double angles. There are some, and I can do some examples. If you want some more examples, I can pull some up. I posted, let me pull something up real quick. I posted a page on Canvas that has more of them. It was optional. So let me real quick find my Canvas modules and share that to show you where that is. You have not missed anything, so just know that. They're not real common. If we look in this module that we've been working through, where did I put them? I think it was under proofs day 2. I did some of them. I could be lying to myself. Let me see. Definitely am lying to myself. Proofs day 1. I had them somewhere on here. They're not showing up where I want them to. Ah, here it is. It's under the lesson 8.3 video. There's a trig identities worksheet 2. We worked through, I'll pull this up. We worked through some of these in class together that day, but there are more of them here for you to do as well. Okay. And today,
Will there be some on the quiz with these kind of things?
I believe that you can use them, but you don't have to.
Okay.
That's kind of where I went with that. Also, just, I think most of you kind of watched that video I put up about the previous quiz and just kind of how stuff is going to be going with the quiz and the test going forward. We're feeling out a lot of stuff, how to quiz, how to test, because some of you, like, I know it's legit, and I know you are working hard, and it's very frustrating as a teacher to know some kids are working really hard and their legitimate work is earning lower grades than some people's not legitimate work. So we are trying to do it in such a way that it doesn't penalize those who are actually doing their work. It's hard to figure out. So the quiz for today is only 4 questions. and it's explain your work next to it. The more it sounds like your own words, the better. Honestly, like I'm not looking for professional sounding stuff here. Multiplying the two terms together, getting a common denominator, things that you're describing that you're doing, you should kind of be thinking of that anyway. So I'm not going to be grading. The more it sounds polished, the more I'm going to be Googling people's phrases to see if it's copied off the internet somewhere. So honestly, it's kind of better that way. And the more work you show me, the better. That's why I kind of shortened it to make it only 4. I'm currently working through rewriting the tests for Monday to make them much shorter, and also make it like so you get a randomized version of one of the versions that I'm making, so that it's a little bit harder to cheat maybe.
Will the test be on lockdown?
It won't be, because all we're dealing with right now is problems with lockdown. And to be honest, that doesn't fix my problem. If you're sitting there on lockdown browser and still have your phone with PhotoMath, doesn't fix anything. So with trying to explain your work, because I know like a few steps are shown on PhotoMath and there's a few explanations, but it's, to be honest, that they make jumps and leaps that I wouldn't expect most students to make. So it's kind of a giveaway on that one. Also, they are allowing, even though we're not allowed to require you to come during a certain time, what I'm going to be doing for the test is asking you to tell me one of 3 different time periods that you will take it on Monday and Tuesday. That allows me to assign it for only an hour, to say you have to take it during this time. One of the 3, and that allows me to kind of control how long people have it, how much is shared. If it's different versions, then I don't know. We're just trying to cut it down a little bit. So we shall see how that will go. But we are going to do some examples today that also include those double angle identities. But I'm going to go back real quick to the homework stuff real quick for you.
Miss Lyman?
Yeah.
So for the quiz, is it like when we explain, is it like step by step we explain, or is it like we write just like a short tiny little paragraph?
It would be like step by step. So next to 1, I replaced cosine squared using a Pythagorean identity. Step 2, I FOILed. It doesn't have to be long explanations. Step 3, I got a common denominator.
Okay.
I will say this, the more you write more steps and more work, the less words you have to write, because some people are jumping from one step to where we already have a common denominator and stuff is multiplied out. If you're making bigger jumps in math, then I need more explanation on the right. But if you're showing me I'm multiplying by cosine over cosine and sine over sine, I need less explanation next to it, if that makes sense. So
Okay, is it bad though if we make the bigger jumps?
it's
like-
not bad as long as you can explain how you did it. That's going to be my thing. Because if I'm being completely honest, on the last quiz, there were a couple kids that made some massive jumps that I am fully capable of doing, but I do not believe they were. And I'm not calling anyone stupid. I'm just saying if it takes like 2 substitutions and 2 steps of algebra in 1 step, I'm going to guess that a high school pre-calc student, knowing how proofs generally go, can't do that. Usually, Aaron, what you make as like a jump, I don't necessarily consider a huge jump.
Okay.
And if you've watched that video, you'll kind of see where some of those big jumps were made that I kind of didn't trust. So just kind of going forward with that. But let me go back to sharing my screen on this one. Did we have more homework questions that we wanted to go over?
I have one on 220.
220?
Yeah.
Scroll forward here. Oops, did I go too far? 220. I did. Yes.
When it's like a sine x plus y, do you have to do one of the sum and difference identities? Or
Yeah.
could you do like sine x plus sine y?
No, the sum and difference identities are for the pure purpose of expanding those. So you have to use those. So
Okay, then could we do this one?
Yep, absolutely. So the sine of x plus sine of y, or sine of x plus y formula, that in this case means that my alpha is going to be my x and my beta is going to be my y. So you kind of see in all of these that the formulas will, you'll be able to use all sorts of different letters and numbers and symbols in all of these. I could do proofs with smiley faces and you could still plug stuff in. So real quick, let me pull up my identity sheet. These ones, because I don't use them often, or as often, I should say, I don't always have these memorized. So let me see if I can pull up my identity sheet. Here we go. So my sine plus formula says sine alpha cosine beta plus cosine alpha sine beta. So that means according to that I'm going to expand this with sine x cosine y plus cosine x sine y. And that's the expansion of just that. I would probably go ahead and change my secants out. Notice this is not like a parentheses plus thing, which means I can make simple substitutions. Secant is the same as 1 over cosine x and 1 over cosine y. So any guesses with what we would do with this, which is basically one term here?
All over.
We can basically distribute that, put both of those terms over it, right? So that's going to be sine x cosine y over cosine x cosine y plus cosine x sine y over cosine x cosine y. So if I just write that next step there to show that I'm distributing that and putting it over both. And again, if you kind of want to know the explanation and steps there, next to step number 1, I would have probably said expand using sum formula. And then my next one would have been distribute. So these aren't long explanations here. Don't feel like you're going to be adding a million steps. In each one, the cosines would cancel. So my next thing would have been cancel top and bottom on both fractions maybe. Sine x over cosine x would turn into tangent of x. Sine y over cosine y would turn into tangent of y. My explanation would be sine over cosine equals tangent, which is just using one of my formulas, and that's my final answer there. So don't feel like you're spending a million years explaining stuff on this quiz as well.
On 224, for number 10, do we have to use, like, we didn't have to use a sum and difference identity, did we?
Or number 10. Nope. That was thrown in there to remind you that these are all going to be kind of mixed.
Okay.
Trying to figure out where we had each one and all that stuff.
Okay.
Any other homework questions we're struggling about right now before we look at some of the harder stuff together? No? All right. So let's take a look at what hard level proofs look like. Hard level proofs would be something like our group activity. I'm going to go through some of this with you to kind of get some thoughts started, and then I'll leave some of it. Also, while I'm kind of talking about this, I sent out an email this morning. My head's spinning with all the things that I am allowed to do and not allowed to do. We can't require you to come in during class time, but we have to require homework due by class time, which means we have to follow the bell schedule instead of what I was doing with midnight. It's very confusing, and I feel like that's actually going to make things worse because I had more people getting late assignments with that than doing the midnight thing, but I have...
Wait, so we cannot have homework due at midnight?
No, not anymore. So the rule now is like, okay, so today is A day. The only thing that I can make due that same day is a quiz or a test. I can't make homework or the video or anything due. So anything I assign today cannot be due for second period until 10 o'clock on Monday for you guys,
Even the video.
even the video.
That isn't okay.
Oh, so it has to be like on the day.
Nothing can be due on the day of besides quizzes or tests anymore.
Miss Lanier, so is this due on Monday though? This, okay.
So I had to kind of reorient the module based off of that so that it didn't block out stuff. This can't be due till 10 o'clock on Monday. With that though, guys, you guys have been doing better with the midnight, the night before deadlines. So just no one's going to get up and submit this by like, for fifth period, that's 7:45 on Tuesday morning. Like no one's going to do that. So just do it the night before, you know? Well, and honestly, like I'm still encouraging everyone to sign in on class day and watch the video so that you're not waiting till like 11 p.m. the night before it's due to do the video and the homework, because that's a terrible idea. It's bad class form. Also, like it's kind of difficult because we are not allowed to require you to do stuff during school time, but like and by we, I mean like me and my husband, we've had to like shut stuff down at like 3:30. Because if not, I'm answering questions till 11 o'clock at night, and so is he, and my kids are screaming, and life is not pretty around here. So like if I don't respond to you after about 3:30, 4 o'clock, don't feel like I'm being rude. I have had to put in like personal boundaries. Otherwise I work all day. And considering my day is supposed to only be 7:30 to 11:30, we're already working the whole day. So life has just been super interesting. But yes, so you can do your work whenever you feel like it between now and next Monday at 10 a.m. for second period. And it won't be late. But please practice good study skills. I'm speaking to the ones that aren't going to do anything stupid anyway, but you know, it's lots of fun. But just know that's where the due date changes have come from, not because I felt like everything was working great doing lesson this day, homework due by the next day at midnight. But you know what? Whatever. Apparently it was different across the board and they want us all to be the same. And
If the people that aren't like doing their stuff on time aren't coming to the Zoom calls, how are they ever going to find out?
they don't. And we can't require you to come to Zoom calls. We're not allowed.
So then how are they? Okay, well, how did they think that was going to work? How did they? Okay, you know what? Just you can continue.
No, I know. Hey, you know what? Frisco ISD, everything for the entire week is due by Sunday at midnight. So I can only guess how that's going.
Oh,
My kids procrastinate an entire week's worth of work until Sunday at midnight.
Is this like a state thing?
Well, no, all the school districts are doing different things. This was like from our administration. I guess parents complained about or not me specifically, but teachers making things due before when the next class would have been. I don't know. Let's all be honest. Like not much work would have gotten done between midnight and 7:45 the next morning, but whatever. I'm adhering to what they've asked me to do. That's all I can do. So this Trig Proofs group activity was linked for you. If you don't have a printer, you don't have to print this. It's 4 questions. These are all considered to be what I would say harder level proofs. So just so you know, for your test, I'm setting up like several different versions so that you're randomly assigned a version. Everyone's getting 2 easy proofs, 2 medium proofs, and 1 hard proof. The hard proof, I will tell you, the hard proof will have something to do with like either one of these questions, or when we're done with these, I'll show you like the extra hard. And when I say extra hard, I don't mean they're going even harder. I'm just saying more hard level proofs for you to practice that I've posted online. So I would do those. I will say those that choose to not figure out the hard level proofs just can't do them on the test. And that, considering there's only 5 questions, that's going to be worth quite a few points. So just be aware of that. So looking at something like question number 1 here, even if you don't have it printed, just go ahead and write this down. This would be, it's not a proof because it's just simplify right now. But just looking at something like this, my goal here is not to do this question for you. It's to brainstorm, like if you had no idea how to do something like this, how would you start? Does anyone have any genius ideas looking at question 1?
You know, the
Water
2
coaching.
sign cosine is a double angle. I think it's sine 2x.
Is a double angle. You could do something with that. I heard another idea somewhere too.
Pull out a cosine.
Okay, so always be looking for factoring. That is a great place to start on this one. If you notice, how many terms do I have? 1, 2, 3, 4. Okay, so let's all do that step to start. I have a greatest common factor of cosine. I'm going to take that, pull that out. Oops, tangent x, excuse me. Now I still have a bit of a mess in here in that parentheses. But once we take the greatest common factor out, it does kind of simplify things down in that parentheses. Any other thoughts of things that we could do?
Could you do factor by grouping on this one?
Yes, that's the quickest anyone's ever come up with that. Anytime you are factoring and you have 4 terms, you can think about this as factor by grouping. So if I factor by grouping, let's take a look at that. That's literally grouping these 2 together and these 2 together, okay? So in that first set of groupings, what can I take out?
Oh, you can take out negative sine, 2 sine.
And I'm gonna just keep it positive because they're both positive, but you can take out 2 sine, which leaves you tangent minus 1. In that second grouping, what could you take out?
A negative.
Negative.
A negative 1 or just a negative, which would leave me tangent minus 1. Remember, in factor by grouping, this parentheses always has to look the same. So what are my 2 parentheses going to look like here when I factor?
2 sine minus 1 and
Sine
tangent.
minus 1 and tangent minus 1. And then I still have this cosine out here that's kind of been hanging out. I could technically simplify this a little bit more if I went to the tangent and substituted in a sine over cosine, but it's not really necessary. This would be fine here to simplify this by factoring. So there are a few, the point of this question is to remember some other algebra stuff that you can do. Greatest common factor, factor by grouping, not something we've seen a lot. So just kind of add that into your bag of tricks on that one, okay? We will come back to that question in a minute with question 4.
On these harder ones, do we have to get to us? Oh wait, that is a single. Is that a single term?
Typically the harder ones are not going to go to a single trig identity or a single term. The hard ones, I'm for sure not just going to make you simplify. They're going to be proofs. So a great example of a hard one would be question 2, if you want to take a look at that. Okay. Question 2 is a good one.
Are you doing on the test too, where like we still have extra problems if we wanted to do them or no?
I am not going to set it up that way because we're going to just I'm trying to streamline it just to make it less.
Okay.
With the explanations, that will kind of give you, because I'm going to separate the points for solving and explanations so that even if you solve wrong but explain correctly, you can still get points for that, so that it should kind of help spread the points out a little bit, if that helps. If I'm taking a look at question 2, anyone have any good ideas as to where to start there?
Sum and difference.
Sum and difference. Okay, and notice how many sum and difference identities am I going to use here?
Those.
2. Okay, so let's just take a minute and expand this one first. So if I use my sum and difference identity for cosine, what is that going to tell me to do?
Like cosine x times cosine y minus sine of x times sine of y.
Okay, and notice that's just for what I've circled in purple. That's not both of them. That's one of them. Then I'm going to do the same thing with the cosine x minus y, but I'm going to use the minus formula. So if I take a look at that one,
It's the same thing, but just a plus sign.
Same thing, but a plus sign. Oops, I wrote this other one wrong in here. Hang on. Backing myself up a step here. I forgot to finish that one. Now, this one makes it totally nasty to begin with, for sure. But as we said with all of these sum and difference ones, expect them to look nasty to begin with. Okay. At least I've kind of taken out the x plus y's in each of them. Any ideas of something we could do next?
Multiply.
Multiply it out. Okay.
Plus
And honestly,
then.
like I hear the question there. Sometimes on these kind of problems, like I don't know anything else to do. So let's just go ahead and treat this like a foiling question. So let's see if we would do that. First times the first would be multiplying all of both of those terms together. If I multiply cosine x cosine y times cosine x cosine y, what am I going to get?
Cosine x squared times cosine y squared.
Yes. Now that's just the first term. So now we got to do the outer terms. Okay, so this is where we have to be a little careful. Outer terms are this one times this one. Now, let's just save ourselves a little bit. What kind of format are these parentheses in?
Difference of squares.
Squares. So someone tell me what happens with the outer and the inner terms if I multiply them all out.
They cancel.
So can you save
They're
your
not that outer.
happiness there? Yes, please do it. Okay. So I'm actually not going to FOIL out the outer and the inner because I know in this case, because they're the same, they're going to cancel out. So we'll just move on then and do the last times the last. So what am I going to get when I do the last times the last?
Sine x squared sine y squared.
Okay. Now, looking at our answer, do we feel somewhat okay about this? Are we getting closer?
Yeah.
Yeah. I mean, given my answer is in two terms with a minus sign in between them and they're squared, I'm getting closer. So now, here is where it comes into play. We have to figure out what to do next from here. And this is one where looking at your answer, because we're aiming to get to cosine squared minus sine squared. But cosine squared x minus sine squared y. Okay?
Morning. I'm on a meeting. I'm on a meeting. No.
All right. Any ideas as to where to go from here or just general thoughts?
Could we use a Pythagorean identity? Or
We-
like
For which ones?
for the ones that it's not for like cosine y and sine x?
And that is a great thought right there. So what she is saying here is out of these four things, I want this to remain and I want that to remain because they're part of the answers. I don't want this term and I don't want this term. So couldn't we use just a Pythagorean identity to substitute for those? Well, let's see what happens if we do. If I want to keep the cosine squared x, I'm going to keep it. What could I put in place of cosine squared y using my Pythagoreans?
1 minus sine squared y.
And it doesn't matter that there's two different variables. You just use those variables and use the correct identities and you'll be fine. Same thing over here. I want to keep this sine squared y because that's in my answer. What could I replace sine squared x with?
1 minus cosine squared.
1 minus cosine squared x. Now we just made this nastier, but it might be temporary. So let's just see. What could I do from here?
Multiply? I have no idea.
And again, that's like, I don't really know. So let's just try something and see. Sometimes you have to back up a step from that. But in this term, I could go ahead and distribute here. And in this term, I could go ahead and distribute here. The one thing that I will tell you to be careful of in the second term, everything is subtracted. Just be careful with that. So if I distribute on the first one, this is what I have. What are we going to get if we distribute essentially a negative squared y on the second one? Sine squared y and what? Positive cosine squared x sine squared y. Now I heard a little ooh. Why are we thinking that now? What happens?
Just then it
Oh,
can't.
That's what happens right here. That and this cancel out, and bam, I have my answer. Now, did we necessarily expect that from that step? Probably not. But that's a great situation for like trying something and just seeing if it works. Anyone lost anywhere on that particular one?
So say if we lose like the X's and the Y's throughout the problem, will like on the test or the quiz, will that be counted off?
This particular question, yes, because there are both X's and Y's.
Okay.
So this one, it really matters that you keep track of what's an X term and what's a Y term. If there is one that is just all X's, or like, here, let me just throw an example at you for a minute. If I just picked one, I could make you, you know, an identity here and say this. I've always wanted to make pull out emojis. I mean, but like, does that matter?
Nope.
No, it's still one of the formulas I can use, and I can go ahead and say, like, prove that.
Can I use symbols then and all my stuff then?
Yeah.
On the-
And here's what I'm going to tell you right now. I have put random symbols on the quiz. Just mess with the system. Okay? And honestly, here is why. My friends that are snapping photos on Photomath, hey, he's learning, shaking his head at this. It's lots of fun. Depending on what symbols I use, Photomath doesn't understand them.
Ooh.
Okay, so if
So smart.
I have Aaron, Ashley, Macy, Nick, Morgan, Emmy, Michelle, Dennis, Blake.
Oh, you got a good group.
We
Is that
do.
Morgan Harvey?
Yeah.
Morgan, hello.
Hi.
Hey, tell Mason I said hello.
I will. He's working right now.
They love your favorite coach from him.
Poor Morgan dealing with me during this. Oh my goodness.
Wait, can you hear me, Leininger?
What's
Okay, because my speaker was messing up earlier.
Oh, no, I can hear you. You're fine. Yeah, so for y'all, like, again, perks of tuning in live, it doesn't matter what symbols I use. You can use your formulas regardless. You can switch stuff out if you want, but it's going to slow down the process if I switch up my formula or my symbols. So I'm doing that. But only, yes, if you lose your symbols, because I do that. If I'm writing out my proofs quick and it's all X's, I lose the X's just because that's how I do them. So if you do, that's fine, except for proofs like the one we just did when there's two of them. So I try to make myself keep my symbols. It's hard sometimes, but I try to. I am going to start 3 with you and then show you where the hard proofs are, and then we'll sign off for today. And if you need extra help with the hard proofs, I can schedule live stuff tomorrow if we need. Everyone take a look at question 3, because 3 has some stuff in it that this is one of those like tools that you kind of want to remember for later. Remember how we said we can always start with either the left or the right, and we typically start with the harder side. 3 is the one place that it doesn't work. On question 3, you want to start on the right. because that's like, if you look at that, you would just say to yourself, well, I could do something on the right-hand side. I could factor out a sine, and then you would get stuck because there's nowhere to go. So here's my question on this question right here. Do we have a formula for sine of 3x?
Nope.
Nope, we don't.
Oh my
And
God.
you wouldn't want to start with that, but it's also why you have to start with it. Let me show you a different way to think about 3x. What if I wrote this like this? Am I allowed?
Oh my gosh.
Have I actually changed the problem?
Mm-mm.
No. All I did was take the 3x and split it into x plus 2x. In one of the homework questions that we did before, I think it was on page 208, we thought about sine cubed as sine times sine squared. This is another one of those thought process things. So if you have something like this that you cannot find a formula for, try to split it up somehow. Now, by doing that, what formulas can I use on this right now?
Sine A plus B.
Yes, I want to talk or look at this as an alpha plus beta. Some of you looking ahead can then see what other formulas are we going to use on this.
Double angle.
Double angle. Because your beta is a 2x, later we're going to use your double angle. But first, let's just use our sine alpha plus beta. That tells me that this is going to expand into what?
Sine x cosine 2x plus cosine x sine 2x.
Okay, so we're using our alpha plus beta formula and just expanding using x as my alpha and, oops, that's a sine, excuse me, sine of 2x as my beta. Okay, now, that's a nice expansion to start with. I want everyone to look at the final answer. My final answer here is all in terms of single x's or double x's.
Single.
Single. There's no two x's in there. That means that somewhere along the way, I need to take out that term and I need to take out that term and replace them. One of them, super easy. Sine of 2x only has one option. What can I replace sine of 2x with?
Do sine. Cosine. Oh.
Yep. And I'm sorry to tell you that the other one, the cosine of 2x, well, sometimes it's guess and check process and sometimes it's not. If you think about it a little bit, it won't be. Look at your final answer. I have 3 options for cosine of 2x. Which one should I use?
Cosine squared minus sine squared.
Nope. Which one should I use?
1 minus 2 sine squared.
Why?
Because we want all sines.
Yes, we want all signs. Okay. Whoops,
Would
what?
it be sine in front?
But I just realized I did that. Thank you. All right, now I currently have a mess, but let's figure it out. What can I do right there?
Multiply.
Multiply. So that gives me sine minus 2 sine cubed. And if I multiply out all of this back here, what am I going to get? 2 sine
Cosine squared.
cosine squared. Okay, not my answer yet, but if I'm still working towards that answer that is all in terms of sines, what's my big problem right now?
There's a cosine.
Yeah, right there. Do I have a way to change that?
Double, Pythagorean.
I could use
1
my,
minus sine squared.
yeah, that's 1 minus sine squared. Now, if I replace that with 1 minus sine squared, what's that going to make me do with my 2 sine of x right here?
Sorry.
I'm
Multiply it.
multiply and distribute, okay? So let's see, I'm kind of losing space. I'm going to move up here. The beginning part's going to say the same, sine x minus 2 sine cubed x. When I distribute, I'm going to get 2 sine x minus 2 sine cubed x. Okay, which ones can I currently put together as like terms?
2 sine cubed x.
That one and that one can go together because they're both sine cubed. Total, that's going to give me more minus how many?
-4.
4.
Sine cubed, right? Yeah,
Whoa.
2 sine x. 3 sine x, which happens to be my answer. So, with the exception of this first step, was any of the rest of that necessarily hard?
It's just long.
Not really. There's a lot of steps. It's
Yes.
not like difficult.
And that's what I need you to know about the hard proofs. Like, don't feel like they're impossible. There is like one twist to it typically, and then it's a decent amount of algebra and steps. But if you just keep pushing through it, you can either get a lot of the way there or the whole way. And there's a limited amount of like twists that I can put on it. So that being said, like for example, today we did the twist on number 3 where the 3x is split into 2 pieces, x and 2x. Now that's something that you can keep in your head for other proofs. Back here, we had 2 different sum and difference formulas and realizing we can FOIL those and make some substitutions. That was kind of the twist on this one. The number 1, there was greatest common factor and factor by grouping. Those were kind of the twists on that one. If I pull up what I have now put on Canvas, just to give you an idea, because I'm going to wrap up here for y'all. On Canvas, I have under your modules, which hopefully we are all.
There are no hard proofs on the quiz, right?
There are no answers on the quiz today, no, because we just talked about these today. So
Hey,
down,
Veronica,
yeah.
What about number 4 on this sheet with the solving the
Yeah.
following equation?
I would have talked about that one in, well, okay, I'll go back to that in a minute. Hang on. Because I didn't see you had to turn this in. So I'll go back to that in a minute. Under our lesson for today, here's kind of my title page here, the video, which I'll post from here in a minute. The quiz comes next before you have to submit the group activity, because the group activity you don't have to submit until Monday. Or Tuesday if you're 5th and 6th period. Then there's the key to the group activity if you want to look at it. This hard proofs thing here is further down. I kind of don't want that there. I kind of want it earlier so that you have it. I'm going to reorder that. I'm going to put that.
Done the group activity together?
We've pretty much done it other than question 4. And 4 is actually contingent on question 1. So I'm going to give you like a way to start that and then let you finish that together or on your own. The hard proofs, I'm going to move up in the module and reorient that so that you can get to it before submitting that group activity. And I don't want you to have to do that and then find the hard proofs. So anyway, but let me just show you these before I have to change the whole thing and move that around again. I'll do that right after this. Well, why is that way? That is just lovely. Why can't I read that? Okay, I'm going to look at that too. There are 5 hard proofs here. They all have somewhat of a twist to them. 1 of them, 2 of them, we already did. Okay, 1 and 2 were off of that formula sheet or the group activity that we did. The other ones all have something to do with one of those twists on them. 5 is cosine and sine raised to the 6th power, so a different way to think about that. 4 has a sine of 4x in there, so you could think about it kind of like we did the 3x, where you split it into pieces, or you can think about it as a double angle identity, one of those ways. And then I've got to redo question 3 so that you can read it. I think if you download it, you'll be able to read it, but let me just double check that. I download this and open it. Yeah, it shows up fine if you download it. So they all have kind of tricks to them. 2 of them we've done already on the group activity. Like I said, there's not a lot of ways for me to do hard proofs. But I've put the key up here to this too. So you should be able to see that. I'm going to bump those up in the module earlier so that you can see. To be honest, if you download the key while you're working on it, it's up to you how much you use that to practice for your test. Things that I would consider doing before my test are these hard proofs, because really there's only 3 of them that you have to figure out. And then anything on page 210. 210 has a lot of medium level proofs that are all kind of different. So yeah, I would look at something like 210. And in fact, on 210 number 13, if you can figure out number 13 on page 210, that might have some bearing on question 5 here in your hard proofs. Those are both good ones to look at. And I'll give you a hint. They're both different ways of factoring. So think about them as some factoring. Other than that, let me quickly go back to that group activity and give you a place to start on that, number 4. And then I will be done. So a place to start on question number 4 here for you. If you will notice, the only difference in question 4 from question 1 is that I have made it an equation that is equal to what?
0.
0. So if you think about what we did in question 1, we took question 1 and we factored it all into pieces, okay? So essentially, you've already simplified question 4, and you could jump to the place that all of your factors that you have, what was it, cosine x and sine x minus 1 and tangent x minus 1 are equal to 0 now. So what you kind of have from question 1, if we're transferring our information, is cosine x, 2 sine x minus 1 and tangent x minus 1 are now equal to 0 because I've added that in. Real quick review from first semester. When we factor stuff out and it's equal to 0 on the right, what do we do with all of our factors?
Put them equal.
Set them equal to 0. And this is a look into what is coming directly after our test. So after this test, what we're headed into next is going to pull everything together that we have done this semester. This is asking me the question, where between pi and, or between 0 and 2 pi is cosine x equal to 0? If I solve this one out, add 1, divide by 2, it's going to ask me the question, where is sine of x equal to 1/2? And this one I already solved out because I was doing that mentally apparently, is asking me the question, where is tangent x equal to 1? So your answers for x are going to be radians using your chart and unit circle, where cosine equals 0, sine equals 1/2, and tangent equals 1. Not all at the same time, but like go through each one at a time. For example, think about your chart for a minute. Where does cosine equal 0 in our chart?
Pi over 2.
I over 2.
2, which then means one other place too, based off of reference. Where is that?
3 pi over 2.
3 pi over 2. And that would be all of the answers for cosine equaling 0. Then I would do the same thing for sine and tangent. Okay? So this is kind of helping us get into what we're going to do next unit. Okay? I believe that I have 6 answers total for this question, if that helps you. So for your call, it's a matter of just finishing this out, and then you will be done. Okay?
Will we ever have to worry about things being undefined when we're finding answers?
Yes. We will talk about that next unit.
Next unit, okay.
And you said there won't be any of the hard proofs on today's quiz?
This quiz
Okay.
is 4 medium level proofs.
So like